Okay, so back to number 8, we were on part B. We were about to find the acceleration. So it'll be FGAX minus FGBX is equal to MA plus MB times A, and we're solving for A. So FGAX we already found. It was 490.5 newtons minus FGBX 392.4 really newtons divided by 100 kilograms plus 50 kilograms, which is about 150. On the top, you get 98.1. Divide that by 150, and you get 0.654 meters per second squared. All right, and then part C wants to know the tension. You can pick either one. I'd probably pick M1 just because it's 100. Math will be easier. So there'll be an FT going this way, and there'll be FG1X going this way. Do sum of the forces is equal to M1A. It should be FG1 was positive, so FG1X minus FT equals M1A. So FG1X minus M1A equals FT. So FT will equal the 490.5 newtons minus 100 kilograms times 0.654 meters per second squared, which when you multiply by 100 is going to be 65.4. Take it away and you should get something like 425. I don't have point anything, which worries me. But, okay, so that's it. All right, number 9. Number 9 was the one that I wanted to get started in class, or one like it. Okay, so in number 9, there's two boxes sitting on an incline. They have different coefficients of friction, just to make your life more exciting. And there's a box hanging down here. So I'm going to call the lower one M1, this one M2, this one M3. And I'm looking to see what the angle is. Okay, so two boxes sitting on an incline connected by a cord which passes over, oh, there's the angle, 30 degrees. The box at the bottom, M1, is 20 kilograms. And it has a mu static, so mu1 static, which is coefficient of 0.4, and mu kinetic is 0.3. M2, the second box on the incline, it has a mass of 30 kilograms, and it has a mu2 static of 0.3 and a mu2 kinetic of 0.2. All right, and the question wants to know, what's the range of masses possible for M3 that would hold this in place? And this was the piece I had hoped to have time to talk to you about today. Okay, so if you imagine there's a force Fg2x pulling down the incline. There's a force Fg1x pulling down the incline. Fg3 is pulling this way. If we were to draw it out, the only thing going this way at this moment, ignoring friction, because we don't know which way friction is going. So we have Fg1x and we have Fg2x. Okay, so you should be able to imagine that there will be a mass where if I keep making M3 bigger and bigger and bigger, there will come a point where regardless of the friction, this system will slide up the incline. And when that happens, friction will be acting down the incline. Agreed? So there's a mass that bigger than that mass, it will, or at that mass and bigger, it'll move up the incline. But then you should also be able to imagine that if I make M3 smaller and smaller and smaller, that there will be a mass where at that mass and lower, this system will begin to move down the incline and friction will act up. And anything between that smaller mass and that larger mass, this system should hang stationary. Because remember, static friction has a range of values. So there's going to be a range of masses for M3 where this system won't move. But when we make it big enough, it will move. And when we make it small enough, it will move. And so that's what this question is asking you to find. Find the mass that's small enough to let it move down the incline. Find the mass that's big enough that it'll make it move up the incline. And then everything in between should be where it stays stationary. Okay, so if you didn't understand it, I'd say stop the video now and give it a try, and then turn the video back on. Okay? Or maybe I stop the video now and make a whole new one. Okay, I stopped the video. All right, so let's do down the incline first. So if it's moving down the incline first, then there will be two frictions up the incline. FFR1, and that'll be static, and FFR2, also static. And this way we're saying is positive. So sum of the forces will equal M total A, but it's just beginning to move, so that goes to 0. Okay, so it'll be FG1x plus FG2x minus FG3 minus friction on 1 minus friction on 2 will equal 0. And we're looking for FG3, so this is M3G, and we're going to take everything else over. So it'll be, oh wait, I'm going to take it over. I take that back. Take this one over and make it positive, and leave all these here. So it'll be M1G sine theta plus M2G sine theta minus mu1 M1G cos theta minus mu2 M2G cos theta. Divide everything by G, which just really means there's a G in every term, so I can just get rid of it. Okay, so M3, so this is down incline, will equal M1, which was 20 kilograms sine of 30 plus 30 kilograms sine, it was 30, right? Yeah, of 30 minus 0.4 times 20 kilograms times cos of 30 minus 0.3 30 kilograms cos of 30. M3 equals, you should get 10.28 kilograms when you do this. That's the value that will allow it to slide down the incline. Now up. Up the incline turns the two frictions around. So if it's moving this way, now we have the four forces down here. Okay, and this way will be positive. So it'll be FG3 minus FG1x minus FG2x minus friction on number 1 minus friction on number 2. It's still just about to move, so this still goes to 0. So M3G, take all the other ones over and they become positive. M1G sine theta plus M2G sine theta minus mu1 M1G cos theta minus, oops, it's plus, mu2 M2G cos theta. Again, the G's will all cancel and fill in your numbers. So cancel with that one too. So M3 will equal 20 kilograms sine of 30 plus 30 kilograms sine of 30 plus 0.4 times 20 kilograms times the cos of 30 plus 0.3 30 kilograms cos of 30. So really the only thing that has changed is the two friction have changed their signs. And now you get a mass of 39.72 kilograms. So anything in between, so you would write it like 10.28 kilograms, M must be greater than that, and it must be less than 39.72. And if it is, it'll hang stationary. Okay, and then the last